doing a big old, like, I don't know, area model, and you can't quite reach the top, you just go down here, and you tap that red X, and it just deletes the whole page.
Huh.
Stick it on, it's magnetic. Perfect.
That's cool.
Alright, so you're going to be starting the show right here on this X. With your hands up here, and you're going to be reading For Math Homework Help Hall in Bakersfield, that whole sign word for word, okay?
Oh, okay.
Alright. Got it?
Mhm.
Feeling good?
Yeah.
Any questions?
No, not really.
No? Are you nervous?
Not really, honestly.
Alright, that's good.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us we have Landon. And Landon, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-435-7. Everywhere else, 1-866-636-6284. The email is dothemath@kern.org or online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right. Nicely done. So Landon, do you have all of that social media, Facebook, Instagram, Twitter, and YouTube? Do you have all that stuff?
I have the YouTube, not the other stuff.
Do you have a YouTube channel or do you watch YouTube?
I watch YouTube.
You watch YouTube?
Yes.
You going to have a YouTube channel sometime?
Not anytime soon. I'm not planning on it.
Well, okay, well, maybe not anytime soon. You never know when these things can happen. But you know what? It's 4 o'clock. And in 2 hours at 6 o'clock, you're going to be YouTube famous. You're going to be on YouTube, and everybody in the world can watch what you're doing. Is that going to be all right?
Yeah.
That's really cool, man. Right? So Facebook, Instagram, Twitter, all that stuff, like a lot of kids, they do that stuff, right?
Yeah.
You've heard of all these things, right?
Yeah.
So they're pretty popular? Mm-hmm. So it's all right that we're going to put you on all those?
Yeah.
All right. Where do you go to school, by the way, and what grade are you in?
I go to Stockdale Elementary. I am in 4th grade.
How is 4th grade?
It's pretty good, honestly.
Yeah? What's so great about it?
Well, I like the math part, and the science is really fun because I got to do a science project.
Oh, good. So you're not saying math is really good because you're on Do the Math.
No.
You actually do like the math?
Yeah.
Okay. So for your science fair project thing, is that something that you're getting ready to do for a contest or just something that you're doing in class?
Oh, I actually already did it.
You did it. What was it?
I did what plastic wrap is the best for preserving food.
Okay.
And the results were that the no cover one, which was my control, was the worst. The parchment paper was second worst, and then the aluminum foil, and then the cling wrap was the best.
What was your hypothesis? What did you think at the beginning?
My hypothesis was actually the cling wrap.
Okay. And why was that? Why did you think that would be the best one at the beginning?
Because it provides just a better seal, honestly, than the other stuff.
Right. Well, I mean, the open one, obviously, right? The
Also,
parchment
yeah,
paper, you
yeah.
can't really get sealed too tightly, but the foil sometimes. So how big a difference was there between the foil and the cling wrap?
Actually, there wasn't a big difference, but there was this small difference, about, on average, 5 days.
Okay. All right. Well, you know what? Maybe we'll do a little bit more talking about that later on. Is that all right?
Yeah.
All right, good. Now, you're here to do some math. So what kind of math have you been working on in class lately?
So we just finished up long division, and now we're starting to work on multiplication.
But a little more difficult multiplication
Yes.
than just doing your multiplication tables, right?
Right.
Okay. So I believe you have a pretty cool way of showing us how to multiply some numbers later on, right? Mm-hmm. All right. Well, we'll get to that, and then we'll have Scott work with you in another way to multiply. And do you know how many different ways there are to multiply numbers?
No, actually.
Do you think it's more or less than 100?
Less. I'm going to say less.
You think less?
Yes.
Yeah, we'll talk about that in a little while, too. All right. So anyway, we've got Landon, a 4th grade student from Stockdale, here today. Don't forget, we have phone tutors available most Tuesdays and Wednesdays throughout the regular school year from 3:30 to 5:30. Phone numbers are at the bottom of your screen periodically throughout the program. Time now for today's Math in the News. Here we are celebrating our 20th season of Do the Math, and we can see some photos from the past right there. A lot of people associated with this program over 20 years, and one of our more valuable people, easy with the back like that there, Jolene, you're one of our very important people here on Do the Math. So first of all, why don't you let everybody know where you are now? So where do you work now?
I'm at Chipman Junior High.
And that's where you were when you were with the Do the Math program, correct?
Half of the time. Half the time I was at Actus Junior High.
Okay, that's right. I do remember you being at Actus for a little bit. So do you remember how you got involved with Do the Math? Like how you heard about it or how you got involved or how you ended up in the studio or anything like that?
I actually do.
Okay.
We brought some of the deaf and hard of hearing students in for a tour of the building, and we came to view this studio. And we started asking questions about, well, how could our deaf and hard of hearing students connect with Do the Math and get math help? So
Over here,
Mr.
if you need to
Lenko
call
and
in
I
get some homework
put
help,
it together
we've got Debbie, Mary Lou,
and brought Sorensen.
Where are they from? There we go. So we can see some
video
right there. So
phone.
you're discussing a math problem with one of the students there.
Actus.
So Alexis from Actus, has Alexis ever been to Holiday Lights at Com? So you are a deaf and hard of hearing instructor.
I am.
And how long have you been doing that?
34 years.
Okay, and with the county the whole time or from someplace else?
No, I've been with the county for 21 years.
Okay, so because deaf and hard of hearing students are serviced through the Kern County Superintendent of Schools, that's how you found out about the Do the Math program as you were in the building with the students.
Yes, that's
And
true.
do you remember approximately when this was, when we had you come on and start this with the deaf and hard of hearing students?
I'm thinking it was like 10 years ago.
About 10 years ago. I know John's been here with me the whole time, so it's been about 10
Yeah.
years ago. And I know you guys were here for more than a season.
Yes. 3 or 4?
Okay, I was going to say, because
4?
I remember a couple of times,
4?
like, things got modified a little bit to make things a little bit easier and more accessible for students.
Yes. We brought some technology.
Right.
Yeah. And we got you started with the Promethean board, too.
Oh, that's right. Oh, yes, the Promethean board. I remember that lovely thing.
Yes.
And some of the earlier smart boards and stuff
Yes,
like that.
yeah.
So, a smile to all our faces. I know you can't see them exactly right now. Wonderful times. Let's take another look at another clip right here, Jolene.
When we multiply, we have to start on the right. So, what's 3 times 8?
Do you remember doing this?
8 times 3 is 24,
Okay.
right? So what are we going to put down here? Put down the 4 and carry the 2. That would be right.
There we go. So working with one of the students. That's Jennifer right there, right?
Right.
Right, because I've tried to
Right.
get a hold of Jennifer also, and maybe we'll get Jennifer down here also and talk about her time with Do the Math.
Right.
And that was before Zoom.
Yes. this
Because
was
most
pre-Zoom.
kids, I mean, I would bet 99% of the students that attend school are familiar with Zoom now.
Right.
Because I'm sure there are some that are going, oh, I don't have to go to school,
Right.
and I don't have to do anything, and they didn't do anything. Right? They're like, I don't have to do, I don't know what Zoom is, I don't have to do it. They said, I don't have to go to school, don't go to school, so I'm not going to do anything. So that's why I'm
Right.
saying 99% of the students
Right.
probably know what Zoom is. But you guys were doing that stuff before that.
Correct.
So are these things that you are still able to do, or kind of talk about how your instruction has evolved from 21 years ago when you started with the county?
Well, I will say that having that experience of teaching through video phone at the time, it was a video phone, of course that what made my life doing Zoom very much easier because, you know, it was all worked out now. You know, I already understood how to do it.
Right.
So that was really helpful. I've always been into technology, so I'm always, you know, encouraging that use of technology.
And speaking of
everybody.
technology, I know I'm kind of throwing you a curveball here.
Uh-oh.
But Q.
Uh-huh.
You have been involved with that for the county.
Right.
And can you talk a little bit about that? So first of all, kind of explain what CUE is for some people that aren't familiar with it.
CUE comes from CUE, CUE, stands for Computer Using Educators.
Right.
And this was an organization that was set up way before the technology we have now. So just to use a computer for educators was a big deal. Well, now we have all this other technology. But we have a local affiliation to CUE here in Kern County we call Kern CUE. But CUE is all about helping teachers learn how to use their technology to engage kids and make learning richer.
Right, so that if the instructor is more comfortable with it, they'll use it more.
Correct.
And the students will see that and both will benefit from it.
Right.
And so I know that there are CUE conferences, you know, national ones and things that I've had an opportunity to go on before.
Right.
And you guys have local conferences and things that people locally can meet and find out what's going on in different areas.
Exactly. We do.
All right. So is there one coming up, or because of the way things are, it's kind of been on hold a little bit?
Things have been flip-flopping between virtual and in-person, but they're scheduled to have a big CUE in Palm Springs in March. Not sure if that's going to end up going virtual.
Because I remember
We're
Palm
just gonna have
Springs
to
was
see.
always the place to
Yes,
have those things.
that's the big one.
Right.
That's the cool one. We usually have our Kern CUE event in the fall, October, November.
Okay. Well, you know what? We certainly do appreciate everything that you did with us here on Do the Math. It was a lot of fun.
It was a lot of fun.
Do you remember any of the signing that you tried to teach me back then? I mean, I haven't retained it, I'm sorry to say, because I haven't been able to practice
I'm really
it.
disappointed, Mike.
When the students were here all the time, I was able to practice it.
That's right.
So how do we, what would you like to show me today?
What would you like to know?
How about, how would we say do the math?
Do.
Do? Or am I going the wrong way?
No, you're doing okay.
Do.
The math.
The math.
Use 3 fingers across. Yeah.
So like an equal
the
sign
math.
kind of, you get the equal, is that what?
Kind
Is that
of.
how that
It's-
comes about? I mean, I'm
it-
just guessing here, but.
It's using the finger spelling M
Oh, okay.
for math. But a lot of the math signs go across like this, like geometry, math, multiplication.
Okay. Well, I was just thinking the way it looks and
Yeah.
kind of going like that. The first thing that came in my mind was an equal sign.
So
All right. Doing the math. There we go. All right, cool. Well,
Do the
Jolene,
math.
thanks for coming in today. Thank you for your participation with Do the Math over the years and for being part of our 20-year celebration. That is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30, and we have Landon, a 4th grade student from Stockdale Elementary, in studio, and we're going to get Landon busy because you've been relaxing so far, right?
Yeah.
All right, over to the board, young man. All right, so you have been working with double-digit multiplication.
Yes.
All right, so I'm going to give you 2 numbers. You may write them however you want, wherever you want.
Okay.
All right, let's go with the number on your face mask, 17. So put that up there. And why do you have 17 on your face mask?
It's my soccer number, actually.
Your soccer number, excellent. I'm going to give you another number, 23. So what I'd like you to do is multiply 17 and 23 however you like. And as you're doing it, explain to Scott how you're doing it and what you're doing, and then we'll go from there.
Okay, so 20 times 7 would be 140.
And Landon, I like the way you're starting. And where are you getting 20 times 7? Where's that coming from?
20 here and times 7.
Okay, gotcha. So you're using the tens column in the 23 and the ones column in the 17, right?
Right,
Okay.
right. And so 20 times 10 is 200.
20 times 10. Oh, gotcha. Okay.
3 times
So
7.
this is 20 times 7. I'm just going to write down because I'm going to get
Yeah.
confused if I don't do that. And this is 20 times 10.
Yeah, right.
Okay. What else are you going to do? Go ahead.
So 3 times 7, 21.
Okay.
3 times 10, 30.
I'm going to move the board a little bit
Then
for
you
you,
add 'em
Landon,
all-
so that you've got some. So hold on a second. I'm going to, both of you guys, I'm going to move the board on you.
I can get us down here if you
Oh,
want.
you're going? Okay, because I was like, why isn't it moving?
Then you
We've
add
got
them all.
3 people doing the same thing.
That's
You
right.
add them all together. It's what
Okay.
I call that's what my class calls partial products. And then you get your answer.
So the numbers you're adding are in the column. So 0, 0, 1, and 0. That's where the 1 comes from.
Yeah.
Where'd you get the 9?
4 and 2 equals 6, plus 3 is 9.
Good. Okay. Gotcha.
And then 1 and 2 equals 3. That's your answer.
Wonderful. All right. That's a great start. I like that. So that'll work, and you have 4 different components, and they come from these different numbers here.
Right.
Can you do this with an area model? Have you done that before?
Yes, I actually have.
Show me
I
the
just
same
practiced
thing.
it
Because
today.
I'd be curious to know if we can correlate the numbers that you have just created with the area model. Okay? Go ahead and see if you can draw a picture of it, because a lot of times students can learn a lot better with the picture. And you're going to use like a square or a rectangle or something like that?
Yeah, I'm gonna do this, and
Okay.
then I like to do this since it's 23.
Oh, okay.
Wait, 17. I've done this with a whole number. I haven't done this with that. It's normally like a 10 or just a regular 10.
Oh, right.
So
Well, what is it? What is 17? If you had a 10 here, it's 10 plus what?
7,
Plus 7. And what about 23?
20 plus 3.
20 plus 3. So if we can use those components, maybe you can make yourself a block like you were doing before, right?
Right.
So you want to do the 20 plus 3 and just the 10? Is that going to be easier for you? Because we can do the
Yeah.
7 later if you want.
Yeah.
Okay, show us what you got. Gotcha. So that whole length, if you want to look at this geometrically, right? The whole length from here to here is 23.
Right.
But you divided it up into 20 over here and 3 there. I think that's a good idea. All right,
Yeah.
so what's going to go on the up and down part?
This would be 10.
Okay, gotcha. Now, could you do the same thing, exactly what you did on the top part, by just adding a little deal here, right?
Correct.
And we'll make a little box here, right? So, sorry, that didn't quite work out, but you know what I mean. So this up here was 20 plus 3, and the whole thing added to 23. We want this whole side all the way up and down here, from here to here, all the way to the top. We want that whole side to be 17, right?
Right.
So, sorry, I erased your 1. If this is 10, how much is left?
This would be 7.
7. Go ahead and put a 7 there. All right, now show us a little bit about how the area model works, and we'll see if we can see some similarities between what you did beforehand and the picture you're drawing now.
So 10 times 20, 200.
Gotcha. So what you've done there, geometrically, is you've found the area of that square, right?
Right.
20 times 10. By the way, do you see a 200 over here on the right-hand side?
Right hand side?
Way over here with the
yes,
stuff that you're...
here.
Ah, look at that. We've done that one. All right. What's next?
10 times 3, 30.
Gotcha. Do you see a 30 over here?
Yes, it's right here. at the bottom.
Hey, so far we're lining up with some things we've already done, which is good. Okay.
7 times 20 is 140.
Almost
Which
like
is
we
right
planned it or
here.
something, huh? Look at that.
And then 7 times 3 is 21.
So we have all 4 components that you did earlier, and now we have a picture of what's going on. And I know that when we did this problem earlier and you checked off each one of these, 20 times 7, 20 times 10, 3 times 7, 3 times 10, you kept that in your mind. That was great that you can keep that organized. I know that I've had some students in my class that just can't keep it in their mind. And so the picture you've drawn here is a great way to keep it in, they don't have to keep it in their mind, they can actually have a picture of it, right? You can keep it on paper.
Yeah.
And then at the end, if you want to know the answer, what would you do to 200 and 30 and 140 and 21? What would you do to all those numbers?
Add them.
You'd add them up together. And we already know the answer because you already did that, right?
Yep.
It's right there.
391.
So this is the numerical representation of what you've done, right? And this is the picture representation of what you've done, but the answer is the same. And so just like we were talking about earlier, there's definitely more than one way. I don't know if we can go over all 100 ways to multiply, but there's 2 ways right here that we've shown here how to multiply and get the same answer twice. And it depends on how your brain works and which one makes most sense to you, but the result is the same.
Well, Landon said there were less than 100 ways.
Thinks there's less?
So
Okay.
what I'd like you boys to do is on the right side, everything that's written in red right there, starting with the 10 plus 7 and down to the 3 by 10, erase that.
Can you erase that for me, Linda?
Yep.
Yeah, that
And
whole
let's
thing
get
right
rid of that, those other 2 right above it.
there. Okay.
Oh, okay.
There you go. All right, so as high as the 17 by 23 is again, let's do it on the far right, 17 times 23 again.
Okay.
Okay.
And Scott, what I'd like you to do is go through with Landon right now a way that is not like those 2 ways, but a way that most textbooks would probably show it for older people that are watching this right now.
Okay. Gotcha.
Okay.
So we'll go back to kind of a standard algorithm,
Right.
Okay.
All right. So we're still going to do, I promise, we're still going to do the exact same things that you did. We're just going to do them a little bit different order. Instead of having 4 components, we're only going to have 2. Okay?
Yeah.
So if this was 17 times 3 and the 2 wasn't there, would you be able to do that problem?
Yes.
Okay. So can you do real quick, just erase that 2? Just erase that 2 for me. We're going to put it back in a minute. But I want you to do 17 times 3 and tell me what you get. Well, 7 times 3 is 21. You put the 1 down there. Oh, carry the 2. Good for you. Talk me through this.
So 3 times 1 is
Good.
3, and you add the 2, which is 5, which would be 51.
Wonderful. So that's the first step of what we're doing. So you already know how to do that. Nothing new to teach you, right?
Right.
What if we had 17 times 20, right?
Right.
Could you do 17 times 2? You definitely could, right? And all we're going to do here is we're going to drop a 0. So can you do 17 times 2 for me real quick? Mm-hmm. 2 times 7.
14.
14. Good for you.
You would actually carry the 1 up here. So
Yeah, so you're going to put the 4 down. Put the 4 down next to the 0. There you go. Good.
carry the 1 up here.
Uh-huh.
2 times 1 is 2, plus 1 is 3,
That's
so that
it.
would be 340.
So now what we've done here is kind of like you did before when you split up 20 into 20 plus 3.
Mm-hmm.
Here's 17 times 3. Here's 17 times 20. And if you went and put back your 2 in here, right?
Mm-hmm.
Then all you could do is put this number down here, 340,
And add them together.
and add them together. Now here's the most important part. You can see from this problem that you've done where the 0 comes from, right? Because we didn't
Right.
multiply times 2, we really multiply times 20.
Yeah.
So when you're multiplying this problem here, and you go to the next line, you did 17 times 3 is 51. That was a great job. When you do 17 times 2, you're actually doing 17 times 20, and that's why we have to have this 0 here. A lot of times you'll see this 0 crossed out, or someone put an X there, or say it's just a space holder. And it's a space holder because we're not multiplying times 2, we're multiplying times 20. Can you add those two things together?
Yes. Ah!
Ah! Got the side of your hand there.
Yep.
Hooray for erasers. That's it. Same answer. And in the spirit of your science project, we probably could have predicted that, right? That would have been our hypothesis. So another way to do it, it's just got a little bit fewer steps, but the answer is exactly the same.
Yes.
Because we've just split up only the 23. We never split up the 17. Okay? And that's another algorithm, and most people will recognize that one as being a way to do it.
Yes.
If you had 3 digits in the bottom, in the hundreds place, you would go one more line and put 2 zeros and keep on going. And I'm sure we'll get to practice some of that here in a minute.
Yes. You boys are both getting wise to the ways around do the math.
There's our hypothesis.
So
for today.
you can do 2 digit by 2 digit, but we're going to not stop there. But anyway, you are done for the moment right there. So pretty good work on that.
Well
so you
done.
found 3 out of the. Now you said less than 100 ways to multiply, huh?
Yeah. I'm starting to think that I'm
Do you
not
know how many
right.
ways there really are to multiply?
How many?
Infinite.
Oh, I like it.
Oh, jeez.
You know how many ways that is? That's a lot in there.
Yeah.
You got to have a lot more ways to do it, huh? We won't do all of them today, though. Anyway, for doing some great work so far today, Landon, you've got yourself a meal courtesy of our friends at Grillin' Burgers. So congratulations on that. So if you get an opportunity to go to Grillin' Burgers, what I want you to do is go in and ask for Lydia. Okay,
Okay.
Lydia loves Do the Math. She runs Grillin' Burgers, and she always supports the program. And she'll make sure that your burger and fries and everything you get is exactly the way you want it. All right? But you got to ask for Lydia. And you got to go, hey, I'm Landon. Nice to meet you, Lydia. I was on the show, and I want to have one of your burgers. Sound good?
Yeah.
All right, good. All right, we'll be back with more right after this.
Hi, I'm Cindy, and today we're going to look at net on the language of math. When you think of a net, there is lots of things that might come to your mind. One would be a fishing net. If you're going to go fishing, that helps you get the fish into the boat. Basketball net. If you like sports and you want to go and play basketball, your goal is to make a basket by shooting the ball into the net. If you have a swimming pool and there's lots of bugs in there, then you may need to use your pool net to clean all the bugs out of the surface or maybe the leaves. Hairnet. If you're an employee at a restaurant, you're probably required to wear a hairnet if you work with the food so that your hair does not end up in the food. volleyball net. You want to hit the ball over the net to the other side. And this one is especially handy right now in Bakersfield with all of the mosquitoes. You may put a mosquito net over your bed to keep yourself from getting bit. All right, in math, a net means none of those things. It does not look like that. A net is a pattern that you can cut and you can fold to make a model of a solid shape. So it's a two-dimensional shape, so it's flat, that you can then fold to make a three-dimensional shape. So you may make a cube, a prism, a cone, any kind of three-dimensional shape. Another definition in math would be like when you're referring to money. The net amount is the amount you have left after you've paid back money you owe. There's also net on paychecks. So when you go out and you get a job and you look at your paycheck and you're going to see your gross amount and then your net amount, which are two different things. And your net amount is what you have left after they've taken all your taxes out. Okay, so here are some examples of what a net look like in geometry. So this is a rectangular prism, has 6 faces, all right? And the net is very useful for different things, especially for surface area. So the net for this model is inside of it. And if we unfold the net, you can see the 6 different faces. So you have these 4 rectangles, and then you have a square on top and bottom. And that's called the net. That can be used to help you find the surface area, because when you flatten it out, it's then just basic shapes that you can find the area of. So you can find the area of this square and this square and this giant rectangle here, or you could do each individual one and you add it all up to get the surface area. All right. We also have, when you have a rounded shape like a cylinder, it looks a little bit different. So a cylinder, what its net looks like is, if we open it up, you'll see there's 2 circles and a rectangle. The 2 circles can be folded back in, and the rectangle would wrap around them to create the cylinder. That's a common shape you see with soda cans, soup cans, things like that. So that is what nets are in math, and that's what we looked at today on the language of math.
Language of mathematics, something new all the time. And most kids, when they heard net, probably didn't think of that type of net right there. Anyway, we do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Phone numbers are at the bottom of the screen periodically throughout the program. Today, we are lucky enough to have another member of the Bakersfield Museum of Art with us today. Michaela, how are you this afternoon?
Hi, I'm good. How are you?
I'm wonderful. So what is your role with the museum, and how long have you been with the Museum of Art?
So I'm an art instructor at the Bakersfield Museum of Art, and I've been there for 3 years.
All right. And today you're doing something that I've done in class, and I know a lot of kids love doing this, tessellations.
Yes, tessellation. We're doing a tessellation art project today. So whenever I was asked to be on the show, I was asked to have a math art project. And whenever I heard that, I automatically thought of tessellation because that is automatically integrated with math. It is all around just math.
All right. As soon as you're ready, go ahead. You've got Landon right there to help you out.
All right. So Landon, first things first, I have lots of pre-made tessellation like stencils that I made.
Okay.
So I just want you to choose one that we can start out with, okay?
Okay, this one looks interesting.
Yeah, that one? Okay. So put all these other ones away. So basically what tessellation is just any shape repeated over and over across any 2D or 3D surface, okay? And so I'm gonna have you put that at this top corner. We're gonna take the pencil, and I'm gonna have you trace that shape, okay? And so there are 2 types of tessellation. We have regular and then semi-regular. And so we're doing regular today. And so what makes it regular is it's just one type of shape repeated over and over. Now, if we're doing semi-regular, that means we have 2 or more shapes. And so here we have Landon only doing this one shape, and that's what makes it regular. After Landon's done tracing this one shape, he will move it on to the next one. Just pick it up. And so pick up this. You're going to move it just straight right here. And just do it over and over again. And as I said before, what tessellation is, it's just that repeating pattern. So it's just a process of just doing this over and over again. And it sounds very kind of a repetitive thing, but the end process is very, very, like, it's amazing what it is.
And where would students see tessellations without even realizing it? Because it's basically just a repeated pattern.
Yeah, so right now we're doing that regular tessellation process, and whenever you think of that, the most one that you see it is like checkerboard. So, or even like tile whenever you're walking, like in any building. Lots of times that could be either regular or semi, depending on what kind of tile it is. Like
Right,
on
and
the
even
floor.
I was thinking like sometimes wallpaper, draperies, things
Yeah.
like that have patterns on them.
Yeah, or even
And-
like clothing design. A lot of that time, that's tessellation. Okay, so now you can do it right here. And this one's kind of going to go off the paper, but that's okay. But yeah, an example I like to use because it's the most common is checkerboard. You're doing really good.
And at the museum, are there ever exhibits that contain tessellations?
Definitely there can be. I can't remember right now if our current exhibition has one or not off the top of my head. But just because there's so many pieces in the exhibition.
So is he lining
But-
it up the
but-
right way, or does he need to move that?
No, he's good.
Okay.
Yeah, this is directly underneath.
Well, who knows? You've been there for 3 years now. Maybe in a decade when you're there, you get a submission from Landon, and he's done some tessellations, and it's being presented in the Bakersfield Museum of Art.
Well, yeah, definitely. I mean, we have the children's programs all the time. Like, we have lots of different kinds where we have children's art shows. And so, who knows if he's in one of those and, like, he decides to do a tessellation piece, he can have his piece in the art show.
You see, the funny thing is that I've actually been to a camp there at the Bakersfield Museum of Art.
Mm-hmm.
We were just studying the elements of art, really,
Mm-hmm.
to me, at least. And it was actually pretty fun. We did a lot of shading and, what's the other one? I forgot what it was called, but we did a lot of that, and we actually did do some tessellation, I guess. I just didn't recognize it.
Yeah.
Do you remember the word value?
Yes, value is
There
value.
you go. All right.
Well, I'm glad that now you remember it, yeah. There's all sorts of different kinds of things that you can do with tessellation. Right now, whenever you finish it, since you are getting close to finishing it, there's a couple of different things that I can have you do, just depending on the amount of time that we have. You can either just straight color it if you want with the colored pencils, or you can stretch your imagination and decide what you see within your pieces, and then create something like entirely if you see like an animal or an object in there.
Okay.
I'll take that from me. Thank you.
So, let's see. Do I see anything?
So do you see anything in there, Landon?
Yeah, so just take a minute, and this is where you kind of have to use your imagination, and you being a kid, I know you have a really big imagination. Just take a minute and look at these shapes that you just drew. What do you see in it?
Honestly, this looks like almost a head right
Yeah.
here. And this here almost looks like the engine of a boat to me. I don't know why. I just have seen them before, and it almost looks like it,
Yeah.
just without the propeller on the end.
Yeah. So, could you draw that on the inside of this?
Probably.
All right. So you can start drawing that.
I'm gonna start by drawing the face. So this would be the eye right here.
And if at any point you need my help, just let me know, okay?
Right here would be the nose, maybe. Right here. Not very good at drawing, but
It's okay.
it's fine. Right here would be the mouth. The ears would go like actually right here, I would think. With like some little stuff in there like going into the ear that makes it look like it. And then down here I'm gonna start drawing the, oh, well there should be some hair, obviously, but forgot to do that. Okay. So there's the hair, should be actually. Okay, so there's the hair. Down here, the motor of the boat. I'm gonna just add a little propeller here.
It's looking great so far. I love it.
It just spins on a motor. Then here I'll draw the, there's usually like some little stickers on them that I see. Like a pattern, honestly. And then the ones I've seen usually actually go like that, and then this will be like red up here and white down here, or blue and white.
Mm-hmm.
Then this is the motor, obviously, and there's usually like there's a little switch, honestly, like right here. And then obviously you go like that if you want to power it on. So that's what I saw in this right now.
Mm-hmm.
All I need to do is color it.
Okay, so we have the colored pencils right there, and then I have some Sharpie markers right here if you want to outline it in black first, but it's up to you. Okay, so let me open this as well.
Okay. Gonna do the motor. So, right now, this is the gray pencil. Where is the red one? Okay, so I'm gonna use the red one, first of all, to color this.
All right.
Right here, I'm gonna actually add a little texture to this. Some like little ridges. Then this will go like really light red, because that's normally how the switches are. Is there a silver? I'll just color black, because it's either silver or black usually. So this right here, the propeller, is just gonna be black, because it's underneath the water usually. And then here, I'm just gonna leave that white actually, because it's usually white. So for the face, I'm just gonna color this a really light shade of orange. And hopefully it looks peach.
Yeah. Sometimes we don't always have the right colors, but coloring it very light always gets the job done. Well, I don't think we're going to have enough time to finish the entire project, but you do have the right idea, and I'm glad we got to finish as much as we did. Yeah.
Yeah, and you guys, it was nice to see that you were able to use some of the elements of art and things that you learned at the museum when you were at that camp on this right now. Remember some of the terminology and apply some of those things that you learned with the tessellation process right there. So Michaela, pleasure meeting you. Thank you for coming in from the Bakersfield Museum of Art. If anybody wanted to find out more information, Michaela, do you know where they would need to go to online?
They would go to the Bakersfield Museum of Art website.
All right. Thank you very much for that. That's at the bottom of the screen. And we'll be back now. The Bakersfield Museum of Art is a type of museum, but there's another type of museum we're going to check out right now. This one's a little underwater.
There is good news for people that want to protect the oceans. That is marine protected areas, but in particular in the United States, it's national marine sanctuaries. Sanctuaries were created specially to preserve, to protect, and to share why they are important with the rest of the country. These areas are all very important because inside them they protect not only coral reefs and fish populations or the migration routes of whales or sharks, they also protect thousands of shipwrecks. These wrecks are protected and they sit in a way as exhibits in an undersea museum. At Thunder Bay, hundreds of shipwrecks, almost perfectly preserved by the cold, fresh waters of Lake Huron, are available for divers to explore and to dive in, while the Maritime Heritage Center back at the Sanctuaries headquarters in Alpena, Michigan, gives visitors on land a chance to see what these ships are all about, why they're important, what they look like, how they went to the bottom, and the people stories associated with them. On the west coast of California, we're working now to document more of these shipwrecks and discover wrecks that the history books or old newspapers say to us are out there, but we haven't yet seen or put our eyes on. So over the last few years, we've discovered a few of those wrecks, and most recently, we found a wreck that wasn't supposed to be there at all. It was a ship that had sailed out and disappeared almost 100 years ago. It still remained undiscovered and one of the top mysteries of the ocean until, thanks to a regular survey of Greater Farallones National Marine Sanctuary, we found a shipwreck, and as we looked at it and examined it, it turned out to be this long missing ship with 56 crew. So not only were we able to solve a mystery, not only were we able to say this is a very important wreck sitting here and protected in this sanctuary, but we were able to reach out to the families of those 56 men and say, after 95 years, we know where your grandfather, your great uncle, your cousins, we know where they are. They're at peace resting at the bottom of the sea in a shipwreck that is now full of marine life. It is their grave, but it is also part of a rich and important marine sanctuary that has been set aside to protect such things. Not only do I think that gave these families some closure, an opportunity to say, at last I know what happened, but also some satisfaction that we're looking out for these guys as we do so many other things in the marine sanctuary system.
Always fascinating. Now, Landon, when you think of the ocean, what do you think about? Like, if I say ocean, what comes to your mind? What do you think about?
I think of Poseidon, I think of fish, and I think of sharks.
Okay.
Those are the immediate things that come to my mind.
All right, so Poseidon, I understand, because I believe in one of your classes you're working with mythology.
Yes.
So you think about Poseidon because he was associated with water and the ocean and stuff like that. And then you said fish, right? That was a big one because obviously that's where fish live, right, in the water. But why specifically sharks, to wrap it up?
I actually watched a lot of Shark Week during the summer, and I was like, these things are actually pretty cool. I kind of want to look at them more, and then I just like got into it a little.
Do you think you would like to do something like that for a living, possibly?
Maybe.
Working in water, marine biology, or something like that, maybe? Or
Possibly.
possibly. You know what? I find sharks are fascinating also. And I find octopus just extraordinary.
Yeah.
If I was your age and I knew about octopus as much as I know now, I would probably go into a career where I just studied everything I could about octopus. They're just amazing animals. And the ocean, you know how much the ocean covers the earth, right?
Yeah.
Do you have an idea of how much water
I
covers
think
the
it
earth?
was like 2/3 or 3/4.
Yeah, like 70% of the
Yeah,
earth is
2/3,
covered with
2/3.
water, right?
Yeah.
And do you know how much of that water has been explored?
Actually, not a lot of it.
Right, not a lot of it at all. Not even 10% of it, probably.
Right.
Right? So there's a lot to be explored. So there's a lot of things to learn and avenues to go into with the ocean. And one of the things we learned last week is, and I wasn't aware of this, did you know that in different parts of different oceans, the amount of salt changes, and it changes on the depth that you're at in these different oceans?
Wow.
You learned something too today, huh, didn't you?
Wow.
And we found out, John, you might remember this, because they were talking about, they found a book that was, I mean, it was down there for a long time. 80 years. 80 years. I was going to say 100, but not quite that long. But the book is in pristine shape. It would be like you could take it right now and you could read it as plain as this and turn the pages and they're not falling apart. And that's because of the salinity of the water and how far down it is. Just amazing, amazing things with the ocean. So anyway, something for you to look forward to. I know when you get into 6th grade, you'll be going to Camp Keep,
Yeah.
and you'll be learning more about the ocean then, because you'll probably go to the ocean for Camp Keep and then spend a week over there and have a lot of fun.
Yeah.
But guess what you have to do now?
Math.
Ah, wise young man we have in studio with us today. Back to the board there, Landon. All right, so you were pretty good at doing 2-digit by 2-digit, so now we're going to expand this, all right? How old are you right now?
I am 10 years old.
You're 10 years old, and you're in 4th grade, so let's go oh, this is going to be beautiful. This is going to be nice, because we got a 0 in here. 104 times, how old do you think I am?
I have
Loaded
Let's see
question.
how long he stays on the show here.
I have no idea.
All right, do you think I'm older than you?
Yes.
Do you think I'm younger than 100?
Yes.
So you got between 10 and 100. Take a shot.
Yeah. 48.
Put 48 down. They gave you a hint, that's wrong, but we're going to go with 48. So anyway, so now what I'd like you to do is work on 104 times 48. If you get a little confused or stuck, because I am making you do a little something that you're not comfortable with right now, Scott's right there to help you out.
All right, then, what do you want to do first? We're going to try to do that algorithm that we learned earlier, right?
Right.
So the first step of that is to multiply 104
Times 8.
times 8.
So we would erase
Don't worry about the
this.
4 right now. That's right. You can either erase it or you can just ignore it for now. Maybe we'll just ignore it and keep it there.
Yeah.
'Cause we don't want to forget it.
Right.
Okay, go ahead. 108 times 4. So what do you
So-
got? 8 times 4.
8 times 4 is 32. I'll put the 2 here.
Uh-huh.
Carry the 3.
Good.
8 times 0 is 0. Plus 3 is 3.
Ah, gotcha. Okay.
8 times 1 is 1.
Oh,
Or
try again.
8.
8, there you go. Okay, so you got that
So
part.
that's 838.
832. So
832.
now, one of the things you might realize is one of the very few times when you can multiply like this 8 times 4 and actually put 32 down is when there's a 0 there. So when there's a 0 there, you can just put the whole number down there because you're going to carry the 3 and it ends up being there. So before you move on to the next line though, do you remember how the algorithm worked? What do you need to do before you start with the 4 times 104?
I need to put the 0 down.
Good job. And where does the 0 go?
The 0 would go as a placeholder right
Absolutely. Why don't you go and put that down there before we start anything at all? It goes right below the 2, right? Mm-hmm. That's it, yeah?
there. Oh, geez.
That's okay.
Something
That's a funky
happened.
0. It's okay.
Yeah.
We know it's not a true 0. It's actually a placeholder, all right? So
Yeah.
we're going to have this, a new number underneath 832, but we have to start in the tens column, and that's because the 4 is in the tens column, right?
Right.
Okay, go for it. Now we're going to do 4 times 104.
So 4 times 4 is 16.
Uh-huh.
You would put the 6 down.
Yeah.
Oh, what happened?
That was pretty cool. You actually, looks like you moved the, move the 1.
So that would be 6. You put the 1 up here, actually. Oh, what happened? There we go.
There we go.
Okay, so put the 1 up here.
Okay.
So that would be 1, obviously, because it's a 0 right there.
Right, now let's make sure you're lining up your numbers, because remember when we add at the end, we got to make sure we're putting them in the right columns, right? So the 0 is underneath the 2, we got that part.
6.
And then you got the 6, and that's underneath the 3, right?
1.
And the 1's underneath the 8, and that's kind of a little trick I showed you. 4 times 4 is 16, you can actually put the whole 16 in there, which is nice.
Yes.
Oh, nice,
So
huh?
4 times 1 is 4.
Okay, and that
which
has
you
its
would
own
put
column, right?
Here, comma.
Okay, what's the
Then-
last step?
Add them together.
Add them together. 3 plus 6 is 9, good. 8 plus 1 is 9, good.
4,992.
Wow, pretty good deal. You want to, let's make sure that this answer makes sense. Can you round this for me real quick? If you were going to round 104, what would it round to?
100.
100, that's pretty good rounding. What about 48? What would it round to?
50.
Good deal. And let's just do this in our heads real quick. What's 50 times 100? Do you know that real quick? Or do you know 5 times
5,000.
1? What is it?
5,000.
5,000. Quick way you can do that, 5 times 1 and then add those 3 zeros. 1, 2, 3. Is your answer close to 5,000?
Yes, it's very close.
It's very close to 5,000. So that means we're pretty sure that we're in the ballpark. If you wanted to check your exact answer, exactly what it was, to make sure 4,992 was the exact answer, what would you do to check it?
I would probably divide.
That's it. You divide 4,992, and what would you divide it by?
By 48 or
48. And what should the answer be?
it should be 104.
104. That's it. So you
Nicely
could check
done.
it by finding out, making sure you get the numbers you multiplied at the beginning.
There you go. All right, you
Well
did
done.
well with that. Erase the board, young man. I've got one more final problem for you.
Aha.
So, Landon, how much do you think a hammer would cost?
I'd say around $10, 15. I don't know.
All right. I don't want an even amount, like $10 or $15. Give me some sense in there and make it under $10.
Okay. Let's do $8.48.
Good. $8.48 is how much it's going to cost for one hammer. All right? You're going to buy two of them. One for you, one for your sister. And you're going to pay with a $20 bill.
Okay.
I want to know how much money you should receive back. We're not even going to deal with tax today. $8.48 includes tax, let's put it that way. All right? I'm going to give you guys 4.5 minutes to solve this.
Oh, we got some work to do here.
Yeah.
Okay, so what do you want to do with this problem? Interesting problem. First of all, you have 848 for one hammer, and you got two of them.
Okay. So what I'm wanting to do, I want to do 20 minus 8, which would be 12. Then I want to subtract 100 minus 48, which is the cents.
Man,
I
there's
know
all
that's
kinds of stuff going
$1.
on, right?
And then you add them together.
And I like the way that you're thinking about that. And I'm not saying it's wrong, but let's think about this. How would they do it at the store? If you were going to the store and you put two hammers on the counter and you were at the cash register, what was the first thing they would do at the store?
They would probably take the money and put it in the cash register.
No money yet.
Okay.
You got to figure out how much money you're going to pay, right? We already know we're
Right,
going to pay with
right,
20,
right.
but let's say we didn't even know. The money's in your pocket. You got a 5, you got a 10, you got a 20, you got a $100 bill in there. Don't even know which one you're going to use. In order to figure out which bill to use, what would they do at the store to make sure that you know how much money you're going to pay?
They would tell you the price.
That's it. So we have the price for one. How do you want to find out the price for two of them?
Multiply it by 2.
Let's do that first, okay? So at least we know how much we're paying at the beginning.
Right.
And your idea was good, but I thought we'd maybe at least go through the process of what the store would do, so it looked kind of familiar, right? Okay, let's see if we can multiply this together.
Okay. I'm gonna
So
put this here.
848, yeah,
so I
and
don't
you got a
forget.
multiplication sign there. And the good thing, there's only one number on the bottom, right? So you don't have to worry about
Right.
that space holder or anything. All right, go to it.
So 8 times 2 is 16.
Good,
Put the 6 there, carry the 1.
good,
2 times 4 is 8 plus 1 equals 9.
yeah,
2 times 8 equals 16.
good,
Then put the decimal point there.
good. Now, here's the next question. How did you know the decimal place goes there?
Because I know that there's a decimal point here, and if you multiply that, that's automatically the dollars.
That's it, yeah, it is. And so kind of what you did was you did the cents times 2, right? You did 48 cents times 2, and that's 96. Then you did the dollars times 2. 8 times 2 is 16, and you put them together. One other way, just to make sure you know in multiplication, if you want to know how many decimal places you have, look at how many decimal places are in the problem, okay? So in this problem here, we have the 4 and the 8, and the 2 doesn't have a decimal place. We're going to take that decimal and go back 2 places, and you put it in the correct spot, so well done.
And I'm glad you explained that a little bit, because if we were doing 848 times 0.2,
Right.
we'd have a different
have a
decimal
totally
place.
different
But
deal,
as
right?
long as you guys are on a roll, keep going.
Okay. So now we know how much we're going to pay. And we don't have to worry about tax today, so that's kind of nice. And we have a $20 bill. And the main thing we want to know is, how much are we getting back? Do we have enough money for lunch, right?
Yeah.
So what do you want to do with this now? We know how much it's going to cost, but we want to know how much change we're going to get.
So I'd like to, I'm going to say it again,
Okay.
honestly. 20 minus 16,
Oh, okay.
which would be $4, and then 100 minus 96, which would be the cents. And you
Right.
would put the decimal point after the 4.
Gotcha. Now here's one thing to think about. If you do 20 minus 16, you've used all your money. And now you want to do 100 minus 96, which is right the cents, but you don't have any cents left, right? Do me a favor. Can you write down $20? Not like I have, but with cents. Can you write it right here?
Yeah.
What would $20 look with cents? Good. So you got 20 in the dollars column, and you have 0 cents. Awesome. Now, if you wanted to figure out how much money would be left after taking away the money that you have spent here, right? We could make a subtraction problem, right? And I'm going to help you set that up right here. One of the most important parts of a subtraction problem, I'm sure you remember, is making sure the decimals are lined up, right?
Right, 'cause
Right.
you guys have 1 minute.
Perfect. This is perfect timing. So can you knock this problem out here? Let's see if we can do this. A lot of
Probably.
borrowing, but you can do it.
All right. So that'll become a 1.
Good.
That becomes a 10, then a 9.
You're borrowing from there. Good.
That becomes a 10, then a
Good.
9.
Oh, you got to borrow from there too. Good.
And that becomes a 10. 10 minus 6 equals 4.
Good.
9 minus 9 equals 0.
Good.
19 minus 16 equals 3.
Oh, I like it. All right. Where's
Point
the decimal go?
there.
Don't forget your dollar sign.
And there.
And there's your change. Is that enough for lunch?
Yes. Wait,
For
no.
a very inexpensive
Yes,
lunch, huh?
yes.
There you go.
Right, for
Nicely
the dollar
done.
menu.
$3.04. Glad you put the dollar sign on there as well.
Great job.
All right, young man, over here. We're going to have you stand right here.
Erase
Yep. Hey, you can erase it. There you go.
There.
So, this is your new uniform. So let's have you face the camera right there so everybody can see your nice tailored uniform, custom made that fits you. And do you know why you have a uniform now?
Yes.
Why?
I did do the math.
Right. And you're now an ambassador for Do the Math. That means you have to tell other people about Do the Math. Can you do that?
Yes.
Excellent. That's all we want you to do. That's your only duty as an ambassador. So, 2 questions. Did you learn a little something today?
Yes, I learned actually a lot.
Yeah, good. Did you have some fun today?
Yes.
That's the big one right there. Glad to hear it. Hey, phone tutors are available until 5:30, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.